trying different numbers out, say, hey, that's going to be a 2. But what we're going to do in this video is to think about how to solve this systematically. Because what we're going to find is as these equations get more and more complicated, you're not going to be able to just think about it and do it in your head. So it's really important that, one, you understand how to manipulate these equations. But even more important, understand what they actually represent. This literally just says 7 times x is equal to 14. In algebra, we don't write the times there. When you write two numbers next to each other or a number next to a variable like this, it just means that you are multiplying. It's just a shorthand notation. And in general, we don't use the multiplication sign because it's confusing, because x is the most common variable used in algebra. And if I were to write 7 times x is equal to 14, if I write my times sign or my x a little bit strange, it might look like xx or times times. So in general, when you're dealing with equations, especially when one of the variables is an x, you wouldn't use the traditional multiplication sign. You might use something like this. You might use dot to represent multiplication. So you might have 7 times x is equal to 14. But this is still a little unusual. If you have something multiplying by a variable, you'll just write 7x. That literally means 7 times x. Now, to understand how you have to, or how you can manipulate this equation to solve it, let's visualize this. So 7 times x, what is that? That's the same thing. So I'm just going to rewrite this equation, but I'm going to rewrite it in visual form. So 7 times x. So that literally means x added to itself 7 times. That's the definition of multiplication. So it's literally x plus x plus x plus x plus x. Let's see, that's 5 x's plus x plus x. So that right there is literally 7 x's. This is 7x right there. Let me rewrite it down. This right here is 7x. Now, this equation tells us that 7x is equal to 14. So this is saying that this is equal to 14. Now, let me just draw 14 objects here. So let's say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So literally we're saying 7x is equal to 14 things. These are equivalent statements. Now the reason why I drew it out this way is so that you really understand what we're going to do when we divide both sides by 7. So let me erase this right here. So the standard step whenever, oh, I didn't want to do that. Let me do this, and let me draw that last circle. So in general, whenever you simplify an equation down to a coefficient is just the number multiplying the variable. So some number multiplying the variable, or we could call that a coefficient times a variable, equal to something else. What you want to do is just divide both sides by 7 in this case, or divide both sides by the coefficient. So if you divide both sides by 7, what do you get? 7 times something divided by 7 is just going to be that original something. 7's cancel out. And 14 divided by 7 is 2. So your solution is going to be x is equal to 2. But just to make it very tangible in your head, what's going on here is when we're dividing both sides of the equation by 7, we're literally dividing both sides by 7. This is an equation. It's saying that this is equal to that. Anything I do to the left-hand side, I have to do to the right. If they start off being equal, I can't just do an operation to one side and have it still be equal. They were the same thing. So if I divide the left-hand side by 7, so let me divide it into 7 groups. So there are 7 x's here. So that's 1, 2, 3, 4, 5, 6, 7. So it's 1, 2, 3, 4, 5, 6, 7 groups. Now if I divide that into 7 groups, I'll also want to divide the right-hand side into 7 groups. 1, 2, 3, 4, 5, 6, 7. So if this whole thing is equal to this whole thing, then each of these little chunks that we broke into, these 7 chunks are going to be equivalent. So this chunk you could say is equal to that chunk. This chunk is equal to this chunk. They're all equivalent chunks. There's 7 chunks here, 7 chunks here. So each x must be equal to 2 of these objects. So we get x is equal to, in this case, we had the objects drawn out where there's 2 of them. X is now. let's just do a couple more examples here, just so it really gets in your mind that we're dealing with an equation, and any operation that you do to one side of the equation, you should do to the other. So let me scroll down a little bit. So let's say I have 3x is equal to 15. Now, once again, you might be able to do this in your head. This is saying 3 times some number is equal to 15. You could go through your 3 times tables and figure it out. But if you just wanted to do this systematically, and it is good to understand it systematically, you say, okay, this thing on the left is equal to this thing on the right. What do I have to do to this thing on the left to have just an x there? Well, to have just an x there, I want to divide it by 3. And my whole motivation for doing that is to have 3 times something divided by 3. The 3's will cancel out, and I'm just going to be left with an x. Now, 3x was equal to 15. If I'm dividing the left side by 3, in order for the equality to still hold, I also have to divide the right side by 3. And what does that give us? Well, the left-hand side, we're just going to be left with an x. So it's just going to be an x. And then the right-hand side, what is 15 divided by 3? Well, it is just 5. Now, you could have also done this equation in a slightly different way, although they are really equivalent. If I start with 3x is equal to 15, you might say, hey, Sal, instead of dividing by 3, I could also get rid of this 3. I could just be left with an x if I multiply both sides of this equation by 1/3. So if I multiply both sides of this equation by 1/3, that should also work. You say, look, 1/3 of 3 is 1. Right? When you just multiply this part right here, 1/3 times 3, that is just 1. 1x is equal to 15 times 1/3 is equal to 5. And 1 times x is the same thing as just x. So this is the same thing as x is equal to 5. And these are actually equivalent ways of doing it. If you divide both sides by 3, that is equivalent to multiplying both sides of the equation by 1/3. Now let's do one more, and I'm going to make it a little bit more complicated. So let's say, and I'm going to change the variable a little bit. So let's say I have 2y plus 2y plus 4y is equal to 18. Now all of a sudden it's a little harder to do in your head. We're saying 2 times something plus 4 times that same something is going to be equal to 18. So here it's harder to think about what number that is. You could try them. I say, well, if y was 1, it would be 2 times 1 plus 4 times 1. Well, that doesn't work. But let's think about how to do it systematically. You could keep guessing, and you might eventually get the answer. But how do you do this systematically? Let's visualize it. So if I have 2 y's, what does that mean? It literally means I have two y's added to each other. So it's literally y plus y. And then to that, I'm adding 4 y's. To that, I'm adding 4 y's, which are literally 4 y's added to each other. So it's y plus y plus y plus y. And that has got to be equal to 18. So that is equal to 18. Now, how many y's do I have here on the left-hand side? How many y's do I have? I have 1, 2, 3, 4, 5, 6 y's. So you could simplify this as 6y is equal to 18. And if you think about it, it makes complete sense. So this is this thing right here, the 2y plus the 4y is 6y. So 2y plus 4y is 6y, which makes sense. If I have 2 apples plus 4 apples, I'm going to have 6 apples. If I have 2 y's plus 4 y's, I'm going to have 6 y's. Now that's going to be equal to 18. That is going to be equal to 18. And now, hopefully, we understand how to do this. If I have 6 times something is equal to 18, if I divide both sides of this equation by 6, I'll solve for the something. So divide the left-hand side by 6. Divide the left-hand side by 6. And divide the right-hand side by 6. And we are left with y is equal to 3. And you could try it out. That's what's cool about an equation. You can always check to see if you got the right answer. Let's see if that works. 2 times 3 plus 4 times 3 is equal to what? 2 times 3, this right here, is 6. And then 4 times 3 is 12. 6 plus 12 is indeed equal to 18. So it works out. Solve for x and check your solution. We have x divided by 3 is equal to 14. So to solve for x, to figure out what the variable x must be equal to, we really just have to isolate it on the left-hand side of this equation. It's already sitting there. And we have x divided by 3 is equal to 14. We could also write this as 1/3 x is equal to 14. Obviously, x times 1/3 is going to be x over 3. These are equivalent. So how can we just end up with an x on the left-hand side of either of these equations? These are really the same thing. Or another way, how can we just have a 1 in front of the x, a 1x, which is really just saying x over here? Well, I'm dividing it by 3 right now. So if I were to multiply both sides of this equation by 3, that would isolate the x. And the reason that would work is if I multiply this by 3 over here, I'm multiplying by 3 and dividing by 3. That's equivalent. That's equivalent to multiplying or dividing by 1. These guys cancel out. But remember, if you do it to the left-hand side, you also have to do it to the right-hand side. And actually, I'll do both of these equations at the same time because they're really the exact same equation. So what are we going to get over here on the left-hand side? 3 times anything divided by 3 is going to be that anything. We're just going to have an x left over on the left-hand side. And on the right-hand side, what's 14 times 3? 3 times 10 is 30. 3 times 4 is 12. So it's going to be 42. So we get x is equal to 42. And the same thing would happen here. 3 times 1/3 is just 1. So you get 1x is equal to 14 times 3, which is 42. Now let's just check our answer. Let's substitute 42 into our original equation. So we have 42 in place for x, over 3 is equal to 14. So what's 42 divided by 3? And we could do a little bit of, I guess we call it medium long division. It's not really long division. 3 into 4. 3 goes into 4 one time. 1 times 3 is 3. You subtract. 4 minus 3 is 1. Bring down the 2. 3 goes into 12 4 times. So 3 goes into 42 14 times. So this right over here simplifies to 14. And it all checks out. So we're done. Let's get some practice solving some equations. And we're going to set up some equations that get a little bit hairier than normal. They're going to have some decimals and fractions in them. So let's say I had the equation 1.2 times c is equal to 0.6. So what do I have to multiply times 1.2 to get 0.6? And it might not jump out immediately in your brain, but lucky for us, we can think about this a little bit methodically. So one thing I like to do is say, okay, I already have the c on the left-hand side, and I'm just multiplying it by 1.2. It'd be great if this just said c, if this just said c instead of 1.2c. So what could I do there? Well, I could just divide by 1.2. But as we've seen multiple times, you can't just do that to the left-hand side. That would change. You no longer could say that this is equal to that if you only operate on one side. So you have to divide by 1.2 on both sides. So on your left-hand side, 1.2c divided by 1.2, well, that's just going to be c. You're going to be left with c. And you're going to have c is equal to 0.6 over 1.2. Now, what is that equal to? And there's a bunch of ways you can approach it. The way I like to do it is, well, let's just get rid of the decimals. Let's multiply the numerator and the denominator by a large enough number so that the decimals go away. So what happens if we multiply the numerator and the denominator by, let's see, if we multiply them by 10, you're going to have 6 in the numerator and a 12 in the denominator. Actually, let's do that. So let's multiply the numerator and the denominator by 10. So once again, this is the same thing as multiplying by 10 over 10. It's not changing the value of the fraction. So 0.6 times 10 is 6. And 1.2 times 10 is 12. So it's equal to 6/12. And if we want, we can write that in a little bit of a simpler way. We could rewrite that as to divide the numerator and denominator by 6, you get 1 over 2. So this is equal to 1/2. And if you look back at the original equation, 1.2 times 1/2, well, you could view this as 12 tenths. 12 tenths times 1/2 is going to be equal to 6 tenths. So we can feel pretty good that c is equal to 1/2. Let's do another one. Let's say that we have 1 over 4 is equal to y over 12. So how do we solve for y here? So we have a y on the right-hand side, and it's being divided by 12. Well, the best way I could think of getting rid of this 12 and just having a y on the right-hand side is by multiplying both sides by 12. Let me do that in yellow. So if I multiply the right-hand side by 12, I have to multiply the left-hand side by 12. And once again, why did I pick 12? Well, I wanted to multiply by some number that when I multiply it times y over 12, I'm just left with y. And so y times 12 divided by 12, well, that's just going to be 1. And then 12, and then on the left-hand side, you're going to have 12 times 1, 4. Again, why did I pick 12? Well, I wanted, we have 1 over 4 is equal to y over 12. So how do we solve for y here? So we have a y on the right-hand side, and it's being divided by 12. Well, the best way I could think of getting rid of this 12 and just having a y on the right-hand side is by multiplying both sides by 12. Let me do that in yellow. So if I multiply the right-hand side by 12, I have to multiply the left-hand side by 12. And once again, why did I pick 12? Well, I wanted to multiply by some number that when I multiply it times y over 12, I'm just left with y. And so y times 12 divided by 12, well, that's just going to be 1. And then 12, and then on the left-hand side, you're going to have 12 times 1/4, which is 12/4. So you get 12 over 4. 12 over 4 is equal to y. Or you could say y is equal to 12 over 4. Y is equal to, let me do that in that, just so you see what I'm doing. I'm just swapping the sides. It doesn't change what's being said. Y is equal to 12 over 4. Now, what is 12/4? Well, you could view this as 12 divided by 4, which is 3. Or you could view this as 12/4, which would be literally 3 wholes. So you could say this would be equal to 3. Y is equal to 3. And you could check that. 1/4 is equal to 3 over 12. So it all works out. That's the neat thing about equations. You can always check to see if you got the right answer. Let's do another one. Can't stop. 4.5 is equal to 0.5n. So like always, I have my n already on the right-hand side, so but it's being multiplied by 0.5. It'd be great if it was just an n. So what can I do? Well, I can divide both sides. I can divide both sides by 0.5. Once again, if I do it to the right-hand side, I have to do it to the left-hand side. And why am I dividing by 0.5? So I'm just left with an n on the right-hand side. So this is going to be, so on the left-hand side, I have 4.5 over 0.5. Let me just, I don't want to skip too many steps. 4.5 over 0.5 over 0.5 is equal to n. Because you have 0.5 divided by 0.5, you're just left with an n over here. So what is n equal to? Well, 4.5 divided by 0.5. There's a couple of ways to view that. You could view this as 45 tenths divided by 5 tenths, which would tell you, okay, no, that's just going to be 9. Or if that seems a little bit confusing or a little bit daunting, you could do what we did over here. We could multiply the numerator and the denominator by the same number so that we get rid of the decimals. And in this case, you multiply by 10, you can move the decimal 1 to the right. So once again, it has to be multiplying the numerator and the denominator by the same thing. We're multiplying by 10 over 10, which is equivalent to 1, which tells us that we're not changing the value of this fraction. So let's see, this is going to be 45 over 5 over 5 is equal to n. And some of you might say, wait, hold on a second, Sal. You just told us that whatever we do to one side of an equation, we have to do to the other side of the equation. And here you are, you're just multiplying the left side of this equation by 10 over 10. Now remember, what is 10 over 10? 10 over 10 is just 1. Yes, if I wanted to, I could multiply the left-hand side by 10 over 10, and I could multiply the right-hand side by 10 over 10. But that's not going to change the value of the right-hand side. I'm not actually changing the values of the two sides. I'm just trying to rewrite the left-hand side by multiplying it by 1 in a kind of a creative way. But notice, n times 10 over 10, well, that's still going to just be n. So I'm not violating this principle of whatever I do to the left-hand side, I do to the right-hand side. You can always multiply one side by 1, and you can do that as many times as you want. Like the same way you could add 0 or subtract 0 from one side without necessarily having to show you're doing it to the other side, because it doesn't change the value. But anyway, you have n is equal to 45 over 5. Well, what's 45 over 5? Well, that's going to be 9. So we have 9 is equal to, why did I switch to green? We have 9 is equal to n, or we could say n is equal to 9. And you could check that. 4.5 is equal to 0.5 times 9. Yep, half of 9 is 4.5. Let's do one more, because once again, I can't stop. All right. And let me get some space here so we can keep the different problems apart that we had. So let's have a different variable now. Let's say we have g over 4 is equal to 3.2. Well, I want to get rid of this dividing by 4, so the easiest way I can think of doing that is multiplying both sides by 4. So I'm multiplying both sides by 4, and the whole reason is so because I have 4 divided by 4 gives me 1. So I'm going to have g is equal to, what's 3.2 times 4? Let's see, 3 times 4 is 12, and 2 tenths times 4 is 8 tenths. So it's going to be 12 and 8 tenths. G is going to be 12.8. And you can verify this is right. 12.8 divided by 4 is 3.2.